This is going to be a really quick video. We're going to go through this week's week 10 and 11 recap on pointers and references, 10-question quiz. It's worth 3% of your grade. We're going to go through it together and talk about any of the confusing stuff that's maybe troubling you. It's just going to be a good recap. So the password is pointers are awesome, all lowercase, no spaces, right there. And we have 15 minutes once we begin. So let's go for it. Question 1. A pointer variable can store blank. What do we think it is? Integer values, double values, addresses of other variables, or string values? So remember, think about the keyword here, value versus address. I'm going to zoom in so that you guys can see this a little bit better. What do we think? What do we think? Addresses of other variables. C. Yes, correct. Very good. Yep, they store addresses. You guys got it. Cool. All right. In order to determine the address of a variable in C++, we can use what operator? What symbol do we use to get the address of a variable in C++? Do we use the @ symbol, ++ symbol, the dereference operator, or yes, you guys got it, the address operator. Perfect. Very good. All right, told you it'd be quick. All right, pointer variables must always be blank before they are used. Dereferenced, static, initialized, or checked. Okay, I'm not asking what they must be before they are read for the value. I'm asking what they must be before they're used. Remember, we don't want garbage data. Yes, C is the correct answer, Kyojin. Initialized. Thanks. Yeah, everyone's on the same page there. Very good, guys. Nice work. You guys got it. C, pointers aren't that hard. Question 4. In order to follow a pointer and access the data that it's pointing to, we must blank the pointer using the blank operator. Oh, I appreciate the compliment. You understand it because the teacher's so good. I don't know if that's the case. Maybe it's just because you guys are smart, but the asterisk operator, okay, so we think the asterisk operator, and then is it dereference or reference? Dereference, nice. Okay, so we want to dereference the pointer using the asterisk operator, or the dereference operator is what we call it. But yeah, that's the symbol for it, is that little star, right? Okay, very good. So that's how we get the value that the data is pointing to. All right. Question 5. Pointers can be used to dynamically allocate storage from the blank at blank. We can dynamically allocate storage from the blank at blank. So we have from the stack at compile time, from the stack at runtime, from the heap or the free store at runtime, or from the heap or the free store at compile time. Oh, we've got some different answers here. Okay, so a couple people think stack at runtime. Remember, okay, so if I'm going to do my little annotation here that I've been doing all day, okay, so here we have our stack. Okay, this is our stack. This is our heap. The stack stores all your local variables, all your global variables, all of your code instructions to run the program, okay? This does not change. It does not grow, and it does not shrink. Once your program's compiled, the compiler knows how big that amount of code is, how many variables are referenced and everything, and it is not dynamic. It doesn't change. So this stays the same, okay? The stack stays the same. Therefore, if we're dynamically allocating storage, which one do you think it would be from? If we're going to allocate storage from something, would we grab it from something that does not grow, or from something that we can take a bunch of free space from? This is system memory, okay? That's what the heap is. It's system memory on our machine that we can go and grab from our RAM or whatever, and we can use system memory and dynamically create or allocate storage, okay? So yes, we want to grab it from the heap, and we want to do it at runtime. You got it. Runtime is while the program's running. Compile time is like before the program's run and while it's getting compiled, right? So yeah, the heap at runtime, right? That's how you want to dynamically allocate storage up here in the heap. So boom, C, you got it. Nice. Okay, question 6. When using raw pointers and dynamic storage allocation, right, creating that array on the heap or something, we must always deallocate the used storage by using blank to prevent blank, delete to prevent memory leaks, free to prevent buffer overruns, delete to prevent stack overflows, or new to prevent memory leaks. What do we do to deallocate storage on the heap? All right, we got someone saying delete memory leaks. So, yep, the delete keyword. Now, is it memory leaks or is it stack overflows? Why would it be one versus the other? What do we think? Going back to that little reference, you have your heap and you have your stack. Okay, so here's your heap, here's your stack. Well, because heap is dynamic, totally, yeah. And this is where dynamic storage allocation happens, yes. But the stack overflow is something that only happens on the stack, right? So we know that this one is wrong. We know that the free and the new is used to create one. So yeah, it's got to be delete and memory leaks. You guys got it. Nice, you're all over it. Perfect, okay. Now, number 7. Blank and pointers can be used interchangeably in many contexts. Function calls, classes, vectors, or array names. We talked about a very special relationship between pointers and so function calls is something that we can do to pass pointers to and from, but we can't use them interchangeably in the same context. Vectors, okay, remember, if we print a vector, it'll print out, whatever's inside the vector. But if we print out an array name, the array stores the address in memory, right? So if I have an array called, ARR, and I do a little cout statement of ARR, and I don't include, okay, obviously, if I include the 0, then maybe it'll give me the value 100. But if I do a cout, okay, whoops, just deal with my rough cout here, and I just do the name, then remember, we get like this weird hex value. You guys remember? You get something like that. We did that in class a couple weeks ago when we were dealing with arrays. Now, this hex value is a address in memory. And pointers also store addresses in memory. So arrays and pointers, array names and pointers are used interchangeably in many contexts. Vectors are different than arrays, right? I'm not actually sure what you get if you print a vector out. We should try that and experiment. All right, question 8. What type of variable can pointers store given the following declaration below? So here we've got int asterisk asterisk ptr semicolon. Can it store integers, addresses of pointers to integers, or any type of integer? What do we think? Addresses of pointers to integers, question mark, someone says. All right, what are some other opinions? Let's have a battle it out. You think addresses of integers or addresses of pointers to integers? I will never be certain of any answer. I know I'm always keeping you guessing. Okay, I'm going to tell you it's between B and C. Okay, so we know it's not an int because we know it's a pointer. All right. Now, we know it's not any type of integer because, again, it's using the asterisk. An address of integers would be if we used the address operator, right? That's my best drawing of an ampersand symbol. And remember, the address of the pointer to integers is what our asterisk means. So it's going to be C, in short. Addresses of pointers to integers. You got it. Nice. All right, a couple more. What does the following code snippet display? So here we've got a pointer that points to the address of an int, okay? And it is an array on the heap, excuse me. It uses the new keyword and it creates a new int array of 5. We have a for loop for int I equals 0 while I is less than 5, well 0 is less than 5, 0 plus plus. We dereference data plus I, and we know I is 0, so data plus 0 is going to be that address in memory equals I times 2. So it's going to be something times 2. And then we also have another for loop for I equals 0, I less than 4, C out data I. So we're just printing it back out. We're printing that data array back out. And then we delete that array on the heap. Okay. No, it is initialized here. We created a new array on the heap. And then we're setting some values. Would it be 0, 1, 2, 3, 4? Would it be 0, 2, 4, 6, 8? Would it be 2, 4, 6, 8, 10? Or garbage data? So it's not garbage data because we are actually assigning it, we're initializing it up here. You think it'd be C, okay, and then someone else said 0, 2, 4, 6, 8. Well, let's take a look. I think we can get a clue here with it being times 2. If I is starting at 0, okay, and data plus I is 0, okay, and this new int is 5, okay, data plus I, 0 times, what 0 times anything is going to be 0, right? So we know that it has to start at 0. So our only options are A or B. And then we know it's times 2. So we know it's going to go in multiples of 2. It's going to go 0, 2, 4, 6, 8. And we know it doesn't start at 2 because anything times 0 is 2. All right, so that one. Last question. Given the following pointer declarations, what can you say about PTR1 and PTR2? PTR1 and PTR2 both contain the addresses 0. PTR1 and PTR2 are both initialized. PTR1 is uninitialized and PTR2 is initialized, or PTR1 and PTR2 are both uninitialized. What can we say? What is true out of these following statements? Both are initialized. Okay, someone said C, someone says one is initialized and one is uninitialized. Okay, so remember when we use C style or list initialization syntax, we use these curly braces. And here we're initializing it to point to the 0 address in memory, right? So this is basically saying it's a pointer, it points to the 0 address in memory. So we know PTR2 is initialized to 0. Up here, we just said, hey, there's a pointer, its name is pointer1, but we haven't set it to anything. We haven't set it to 0, we haven't set it to anything. There's going to be garbage data in there. So PTR1 is uninitialized. And PTR2 is initialized, even though it's initialized to 0. That's something that C++11 came out with. All right, so save and submit. There you go. That should be pretty good. We took 13 out of 15 minutes, so pretty good on time, and 100 out of 100. Very good. All right, I'm going to unzoom out of that. If this is if you're watching the video, thanks for watching. Please watch the rest of the videos in the class. I know the quizzes, are worth marks, but there's also an assignment that's going to be worth quite a few marks as well. So please take a look at what we covered in class today with the pointers. I'm going to end the recording here.